Example 7 is an example of uniform motion problem. It is a uniform motion problem. What that means is something is moving, maybe two somethings, but they're not moving at a variable rate. They're maintaining the same speed the whole time, as if a car had the speed control, the cruise control on, thank you. So what we have here is a man leaves home driving at the rate of 50 miles per hour. When his daughter discovers that he has forgotten his wallet, instead of calling him on his cell phone, she hops in her car and drives after him at the rate of 65 miles per hour. I figure maybe he was going to pay for her prom dress or something, and she needed to it was important to her that her dad have the wallet. And we would like to know, how long will it take her to catch her dad if he had a 15-minute head start? What we know is that distance always equals rate times time. And what we have is who leaves home first?
Dad.
The dad. So the dad leaves home. And we don't know how long he's traveling, but we know how fast he's traveling. He's traveling at 50 miles per hour. That's his rate, correct? So his rate is 50 miles per hour. Okay? We don't know his time. In fact, we're looking for whose time? The dad or the daughter's? We're looking for the daughter's time. Now the daughter leaves home, and at some point she catches up to him. And she's driving at a rate of 65 miles per hour. Thank you. And what we're interested in is her time. How long does it take her? So we'll call that T. That's our variable. That's what we want to know. How long does it take her to do what? Catch her dad. So basically, we want to know how long before her distance equals her dad's. Do you guys understand that?
Yeah.
That's what we're interested in. When she catches him, they will have traveled the same distance. Not for the same time, not at the same rate, but the same distance. Their distances will be equal. So we have to figure out an equation that will allow us to do that. Let's talk about the dad. The dad, he was traveling 50 miles per hour for how long? 15 minutes longer than or shorter than the daughter?
He was driving longer.
He left first, so he was going longer. Especially he was driving slower, so obviously it's going to take him longer, right? So the dad's time is going to be T plus 15 minutes. Make sense? Okay. So we know that dad's distance then is his rate times his time. So it's 50 times T plus 15 minutes. Well, here's the problem with 15 minutes, guys. 50 is 50 miles per hour, not minutes, and your units need to match. So you can't add 15 minutes. You have to add how much of an hour? 0.25 or 1/4. 15 minutes is a quarter of an hour. Those are the little things that make these problems so difficult. So plus 0.25. That's how long it took him. It took him however long his daughter went plus a quarter of an hour more. And that has to equal her distance. Her distance is given by her rate, which is 65, times her time, which is just plain old T. Let's distribute the 50, and we get 50T
12.5.
plus
12.5.
12.5. 12.5 what?
Hours.
Hours. That's a lot of hours. Equals 65T. Then we subtract 50T from both sides. And that gives us 12.5 equals 15T. Divide through by 15, and it looks like T equals
0.83.
point what?
5/6 or 0.83.
Okay, give it to me as a fraction since it's a repeating
Five
test.
sixths.
5/6. 5/6 what?
Over an hour.
of an hour. How much is that?
50 minutes.
Very good. How'd you know that?
He said it's
50 over 60.
83% of hours.
Obviously 50 minutes. Yeah,
Yeah.
83% of an hour is obviously 50 minutes. And did it say you had to give it in minutes? No, so I would take either one. I would take 5/6 of an hour. I would take 0.83, with the line over it of an hour, or I would take 50 minutes. But be very careful and make sure that you use the appropriate units throughout the problem.